Okay, so the next thing that we're gonna do is one of our favorite parts of the conference. So we started this 2 years ago. This is gonna be our 3rd year. And we started soliciting Cool K-PACs from our customers. And what we wanted to do is just kind of showcase some of the ways that people use the technology to accomplish different things that they do and solve some of the problems that they solve. So we have 3 people that entered, or 3 finalists this year. Nick Cassidy from Navistar, James Robleski from Auros Knowledge Systems, Daryl Yarbrough from GM. So what we'll do is we'll have them come up. We'll give them 5 minutes, 5-10 minutes to kind of explain what their knowledge packet is. We'll demonstrate how it works, and then we'll vote on who wins, and the winner will get to take a picture with the trophy that is to your left. So for the first presentation, we're going to ask Nick Cassidy from Navistar to come on up.
Okay, so this is one of our fasteners out of our material group. It's actually out of joining and mechanical fastening. So it's fastener coating selection, mitigating galvanic corrosion at joints. So frequently as you're going across the vehicle, different areas, trying to choose the right fastener is a tough situation for many people. They may choose the right size or type of fastener, but when you start getting into the coatings, there's frequently problems at that point. So we have all kinds of standards in regards to that. We have standards in regards to the material, standards in regards to the fasteners, standards in regards to the coatings on the fasteners, standards for the coatings provided on the actual materials. So with that, we're able to gather this data, as you see as Josh is scrolling through, and what it turned into was a large lookup table. So all kinds of different variations as far as what you would choose, and trying to guide them to the right fastener choice. The process prior to this was you would go to materials with, hey, this is what I'm trying to do, and depending on which materials engineer you got, which specs they pulled up, and what their knowledge base was of what tests we've ran, they could point you to maybe one of these fastener choices or maybe not. So with this, we've got kind of the generic table right up at the top. If you want to click on that one, we can see that a little more blown up. So based on what the substrate was, trying to do what the actual fastener finish was is the second column, and then the appearance based on a salt spray test, whether it was, it just disappeared. Whether it was a good solution and seen as a high quality pass at that level, or a not tested is the gray and the NT, whether it was a full out failure, and then what the actual location, suitable locations was, is what's kind of listed out on the right. So if we go back to the K-PAC, and then there's if we scroll all the way down to the, I believe it's the documents section, we actually have in the support document section, if we were in our system, a link directly to our physical test reporting system, where I can get to all the actual test report data of what's been done in regards to these fastener tests. So it's a collection of multiple tests, collection of multiple standards. Trying to gather that as an engineer and get to the right stuff is a little tough. So if we go to the lookup table portion, which I don't know how many are familiar with using lookup tables as part of a K-PAC, but it's still a value table format. We can say we're going to do a brand new bumper on the front of a truck. It's going to be steel, it's flat rolled, and we're going to start with that we're going to do a pre-treat and a powder coat, just nice, simple, plain, basic bumper, and change the vehicle location to the bottom one, highly visible exterior of the cab. So this is it, bottom one. So this is the outside front bumper, rear bumper on a vehicle. So we hit the resolve, and we actually have a response as far as suitable fastener types that type of coated steel is not recommended for that vehicle location. So apparently we don't want just that level of coating, so we can change that, and we'll just jump forward. Let's go to the base coat, clear coat, and we can resolve that. Still same answer. So let's bump up again. And let's just skip all the way to the HDG. And then resolve. So here it tells me, okay, my suitable fastener types for outside of the cab, steel flat rolled bumper with that type of a coating, a pre-treat, E-coat, base coat, clear coat, is a steel bolt with the zinc aluminum clear finish, or a type 18-8 stainless steel. Now, program management comes along and says, wait a second, I want to have a bright option for that bumper as well. So let's change our steel to one of the stainless steels. And let's change our finish, since at that point it's going to be bright, to a no coating. And let's hit resolve again. So for this option, it says I would need a type 18-8 stainless steel. So now, as the engineer, I can say I can choose a bolt that will work for both of those bumpers, have a common bolt for both applications, and it works. And then when I go back and management's like, why'd you choose that bolt? We can go back over to the details tab, and we can scroll down, and we can say, okay, back, I think it's the second one. So stainless steel aluminum clad bumper, okay, that bolt in 18-8, if we actually read the detail that's really tiny in there, is bolt number 5. That's why I chose that one. I now have a visual representation that I can also share with why did I choose that versus the bolt on the far left would have been that zinc clear. So clearly I can go back up to management and I can say, okay, yeah, I'm paying more for this bolt. I'm keeping it common for manufacturing, but I'm also making sure you've got that proper visual appearance on the outside of the vehicle. So instead of each time that question comes up, whether it's inside, outside, visible bracket, not visible bracket, they can use this table and get to a finish. It's not driving them all the way to the exact fastener because, well, is it a bolt? Is it a rivet? Is it a nut? Is it the washer? But I can guide them to look at the right finishes to then narrow down that solution and be designing the joint instead of worrying about a fastener coating and not bothering a material engineer every time to dig through specs for something that should be pretty well defined.
Right on. Thank you, Nick. Appreciate it. Thank you.
Thank you.
Yep. Once we have all 3 of the contestants or the finalists present, we'll then start the polls and we'll vote on who will win. So our next presenter is James Robleski from Auros Knowledge Systems.
All right. So for those of you who don't know me, I'm Jimmy Robleski. I work for Auros Knowledge Systems, and I'm an application engineer and release coordinator. So part of my job is to work with Josh and Jeff to identify any roadblocks in our release process and to identify where we're at in our particular release. So this K-PAC helps us identify any roadblocks and where we're at a particular release. So what this K-PAC does is it shows us the critical to quality internal readiness requirements. So what the value table is showing, the first column is the release phase. So at each release phase, we have 6 different critical to quality measurements that we have to meet at a particular phase. So at alpha, we need to be 55% enhancements coded. We need 30% enhancements audited and 15% enhancements closed. So these are just some measurements that help us understand where we're at in the release and whether or not we can move to the next phase. So if we go to the rule processing engine, we can kind of show how this works. So I'll have Josh put in some percentages. So Josh is doing this manually right now, but in our process we have KPIs that will directly look into the system and mine this data dynamically. So we're not actually in our process filling this out manually. The system is just mining that data, and we're just running the rule processing engine to show us whether or not we're ready for a particular release. So if Josh clicks evaluate, we can see that we're meeting all of our critical to quality measurements for the alpha phase. And if we change it to beta, we'll see that we're also meeting our critical to quality measurements for the beta phase. But as we move into, say, the pre-RC phase, we can see that we're not meeting some of our requirements, so there's some work that needs to be done in order to move on to the final phase of our release. So we can see, using this value table, that our coding is up to par, but we need some work to be done in closing the issues and actually testing the software issues that are coming in. Okay? Thank you.
All right. Thanks, Jim. So our third finalist is from General Motors, Daryl Yarbrough.
Okay, I had to simplify this so I wouldn't show anything I wasn't supposed to show. So it's pretty trimmed down. But what we have here is a K-PAC, and we had different clearance values depending on if it was a car, a truck, or an SUV. And typically in the past, we had entered that information via text, and you had to read an entire paragraph to discern what it was going to be. So we wanted to put it first in a view that was easy to quickly scan and see that if I am at between 20 and 30, I'm going to be yellow if I have a car, and it'll be 25 to 35 if it's a truck, it'll be yellow. So I can quickly scan, see what my values are going to be, and I can see what my corrective action is for any particular result. So if we go in and rule process this, and so if I take a measurement within the CAD system and then I select the type of vehicle, it'll return the value as well as the corrective action or any corrective action that would be required. And you can see if you change the type of vehicle, it'll update, and it's dynamic. Okay? And we can furthermore take this, put it in an assessment, and actually we have a connector, and so we can read this into NX, create a measurement, tie the measurement to the parameter, and then push that back out and get this information pretty much for free. And if we do it within the assessment, it'll automatically set the conformance state depending on what our result is. So in this case, it's red. If we change it to 28, that's going to be yellow. And if we were to change it, if it's an SUV, we selected the wrong vehicle type, and it'll be green. That's it. Simple.
All right.
All right.
Thank you, Daryl. All right, so those were our three finalists for the K-PAC competition this year. The voting will be the same way that you do the poll questions. So if you open up your app and go to the activity ribbon in the menu, there should be a question there where you can vote. We'll leave the voting open for a few minutes until everybody gets in. a couple more minutes to put some votes in. I think we've got about 65 people here. All right, I think it looks like Mr. Cassidy is our winner. Thank you, Nick. Come on up and get your trophy. We're gonna make you take a picture so we can do some marketing stuff. But we appreciate all three finalists. This is one of, like I said, this is one of our favorite events of the conference, so we appreciate you guys entering. We'll solicit more entries next year, and if you're interested, we would love to have you enter the contest as well.